Alrighty. Today, we're going to talk about angular velocity and linear velocity. Angular velocity is how fast you're going around in a circle. Okay? Literally, that's basically what it is. How fast you're traveling around in a circle. So angular velocity is some sort of a W type thing. And it is how far you're traveling around the circle, which is the angle that you're traveling, which is theta divided by the time it takes you to travel that much of an angle. Okay? So that's angular velocity. Yep. So if you go the way around the circle, 2/3 of the way around the circle is about 4 pi over 3. That's your angle. If you do it in 6 seconds, we can figure out your angular velocity. Your angular velocity would be 4 pi over 3 over 6. Now, what kind of a fraction do you call this fraction? You learned this in Algebra 2. Well, you were taught this in Algebra 2. You maybe didn't learn it, but you were taught it in Algebra 2. Yep, you're right. A complex fraction. A complex fraction. So, this is 6 over 1, really, in the denominator, right? So now I have a fraction and a fraction. Multiply by the reciprocal of the denominator. That cancels that out. Now we'll have one fraction. 4 pi over 18, which reduces to 2 pi over 9 radians per second. So, if 2/3 of the way around the circle, you start right here. 2/3 of the way around is about that far. Okay? So, if we're talking in radians per second, we went this far in 1 second, this far in 2 seconds, this far in 3 seconds, this far in 4 seconds, this far in 5 seconds, and then we got to here in 6 seconds. So each of these slices would be 2 pi over 9 radians. Because in 1 second we went 2 pi over 9. In the second second we went another 2 pi over 9 or 4 pi over 9. In the next one we went another, which would be 6 pi over 9, which is the same as 2/3 pi, and so on. Okay? Now, we don't talk about radians per second that much in the real world. You gearheads talk about RPMs. What does RPM stand for? Revolutions per minute. Revolutions per minute. Okay? So if you step on the gas and your vehicle, your tachometer goes to 2,000 RPMs, Okay? What's happening is the inside of your engine is going around, the crankshaft is going around 2,000 times in 1 minute. Okay? So, revolutions per minute. Now, how does revolutions per minute relate to radian per minute? Well, we know in 1 revolution, there are how many radians? 1 time around the circle is how far in radians? 2 pi radians. So there are 2 pi radians in 1 revolution. So if we had, if we're going 1600 RPMs, how many radians per second is that? Okay, and I stress the word second because that's important. So we start out with 16 RPMs. We don't write it as RPMs. We write it as revolutions per minute. So we write the revolutions on the top, minutes on the bottom. Now, we just said there's 2 pi radians in a revolution. What we're converting to goes on top. What we're converting from goes on the bottom. So we're going to multiply by 2 pi radians over 1 revolution. And that cancels out our revolutions. And now I have a radians per minute. But we're not done. Because what do I want it in? Revolutions per second. So I need to get seconds on the bottom. I need seconds down here on the bottom in my denominator. Because it's in my denominator here. So I need it in my denominator. Minutes is in my denominator. So where's minutes going to have to go to cancel it? In the numerator on top. So how do minutes and seconds relate to each other? There's 6 seconds in 1 minute. So on your calculators, and you all need calculators today. If you don't have your calculators out yet, get them out now. Let's take 1600 times 2 times pi, and then divide by 60. And give me the decimal answer. I don't want an exact answer in terms of pi. I want a decimal answer. What is our decimal? And it's fairly big, but not humongous. What'd you get, Molly? You don't know. Something into your calculator, but you don't know what it is. What'd you get? No, that's good enough. Everybody get 167.55? Okay. That would be radians per second because minutes cancels with minutes and I'm left with radians per second. Okay? That is angular velocity. How we're going around in a circle. Linear velocity now. What is linear velocity? Well, that would make me think I'm going where compared to an angle? It's on a straight line. So, if I'm going around a circle, how would that compute to going into a straight line? That's how you got to think of linear velocity. So, and actually I drew my direction. So if I'm going this way, my wheel is actually going this way. But if you're going around, how far do you travel in a straight line with like a tire going around in a circle? Okay, how fast is that going down the road? So linear velocity, which is the letter, we'll see what the letter for linear velocity is v for velocity, equals, and it's not just the angle you go, but it's also dependent on how big the wheel or the tire is. Because a little tiny wheel like this would have to go around a lot more times than a big wheel like this to get the same distance. Okay? So it all depends on how big it is, which the distance around it is called the arc length. It depends what arc length we've traveled. Yes, circumference is correct, but if our arc length is more than one time around the circle, it's the arc length. So arc length is S. So it's the arc length over the time. Okay? How far you're traveling involving the radius. Okay? Because arc length depends on the radius. So it's the angle times the radius divided by t. Okay? It's the angle times the radius divided by t. Okay, and we'll get to those problems, but we're going to jump here now to the next little page where we're looking at some examples. All right, so I'll let you answer the first two. I'm not even going to go over that. So when we do these angular velocity problems, it's all in back to physical science. Remember how you used to cancel units. Cancel units so you get, or you did it in chemistry, or you should have done it in chemistry. Those of you, how many of you are seniors? All right, you should have done it in chemistry last year, whether you did it or not, I don't know. But you should have done it in chemistry last year where you see, well, this cancels with this, so what am I left with? Radians per second. So 3 times 2 pi is 6 pi. You know, that we can keep in exact answers in exact terms of pi really easy. Okay? Okay. So then revolutions and revolutions cancel, so what am I left with? Feet per minute. Then 6 times 54 is the same 3 times 108, which is 324 pi feet per minute. Okay? So you just cancel as you go. Radians cancel with radians, minutes with minutes. You get revolutions per hour, and you just multiply and divide. Now be very careful when you divide. I'm going to show you how to do this wrong. So then hopefully you do it right. Because some of you will mistakenly look at this and say, well, I'm going to take 6 divided by 2 pi times 60. And that's a wrong answer. Others will say, well, you should do it this way. 6 times 60 divided by 2 pi. And you still get the wrong answer. Now, how should we put that in? You need parentheses around the 2 pi. It's 6 times 60, multiply the numerators together, divided by parentheses 2 pi. Because pi is in the denominator. The calculator doesn't know order of operations. The actual answer is 57 point, round to the nearest tenth, 57.3. Okay? So this is what I tell my people. And you're my people. You're my homies. We got 6 times 60, and then divide by 2, press equals, then divide by pi, press equals. Do it as 2 separate steps, and it'll always be fine. But if you divide by 2 pi and don't put in parentheses, you're going to get it wrong, as I did on there. Okay. We're good with that. Let's go to number 9 here. Okay. A windmill for generating electricity has a blade that is 30 feet long, depending on the wind. It rotates at various velocities. Find the angular velocity in radians per second for the tip of the blade that's rotating at 55 revolutions per second. So I have to change 55 revolutions per second into radians per second. Okay, what do I multiply to change revolutions into radians? 2 pi radians over 1 revolution. And now all of a sudden I have radians over seconds. So it's 100 pi, or 110 pi. 110 pi is like 326 radians. I'm just going to put 326. It's probably not the right answer, but about 326 radians per second. Okay? Now, what didn't I use from that question? The length of the blade. When you do angular velocity, the radius is not important. You don't use the radius. Angular velocity is just the arc length, or it's not the arc length, it's the angle traveled, because it has nothing to do with radius. It's the angle traveled divided by the time. Okay? Now, when we get to 11, then it is important. Okay? A typical saw blade rotates at 3,650 revolutions per minute. All right. All right. So Caleb decides he's going to make an electric go-kart, and he's going to put a saw blade with a tire on it to move that go-kart down the road. And it's going to travel. So he picks out a table saw to flip. He takes the table saw, flips it upside down, puts a tire on where the blade goes, and he's going to make it go down the road. He picks out a saw that goes 3,650 revolutions per minute. Okay? And then he gets a 12-inch diameter tire to push him down the road. How fast is he going down the road with his go-kart? Okay? Well, if I have 3,650 revolutions per minute, I have to change revolutions into radians by going 2 pi radians per 1 revolution. Now I have radians per minute. I want miles per hour. So how do I change radians into miles? Well, radians deals with the what of the circle? Radius. Radians and radius are the same thing in this example. Okay? So what's the radius? Well, if it's a 12-inch diameter, it's a 6-inch radius. 6 inches per 1 radius. Radian, radius. Radians, cancel. Now I have inches per minute. I need to change it to miles per hour. Okay? I got to put inches into miles. Well, I don't know how many inches are in a mile, but I know how many inches are in a foot. How many inches are in a foot? 12 inches in 1 foot. Why did I put inches on the bottom? So they cancel. So now I have feet per minute. I need to get it to miles. So I put miles over feet. How many feet are in a mile? 5,280. You will have to memorize that. If you do not know that yet, you will have to sink that into your brain. There is 5,280 feet in a mile. Write that down somewhere if you do not know that yet. 5,280 feet in a mile. Now I have miles per minute. I need miles per hour. So I need hours on the bottom. So that means minutes on the top. I don't even mean minutes in an hour. 60 minutes in 1 hour. So on your calculator, you take 3650 times 2 times pi times 6 times 60, and then I press equals. Do the whole numerator, press equals. Then divided by 12, press equals. Then divided by 5280, press equals. How fast is Mr. Pedersen's go-kart going down the road? 100 and what? About 130 miles per hour. Right? He's cruising. Sounds like a death wish. All right. So let us get going on this, on your first assignment, the first 11 problems, and we'll talk about some more problems to do over Labor Day weekend.